My name is Bill. This video is on solving atomic species balances with Excel. I am going over Homework 4, Problem 2 from Fall 2011 Material and Energy Balances class. A mixture of NH3 and air is fed to a reactor at rates of 1000 moles per hour air and 100 moles per hour NH3, where they are reacted to produce a mixture of gases comprising 3 mole percent O2, 6 mole percent NO, and the rest N2, NH3, H2O, and NO2. If the fractional conversion of NH3 is 0.7, calculate the outlet molar flow rate in moles per hour of each species. There are several reactions occurring, but because we are using atomic species balances, we can ignore these reactions. To begin with, we start by drawing a diagram. There are two streams going into the reactor and one stream going out. N1 is 100 moles per hour of NH3. N2 is 1000 moles per hour of air, which is 0.21% O2 and 0.79% N2. Going out, we have N3, which is the total amount of moles out. N4 is the amount of O2, N5 is the amount of NO, N6 is the amount of N2, N7 is the amount of NH3, N8 is the amount of H2O, and N9 is the amount of NO2. The reason we have an N3 is that some of our equations are expressed in terms of the total number of moles out. Since we don't want one variable multiplied by another in order to solve the problem, I have broken this up into separate variables. You'll see that this makes the math a lot simpler, even though this is a slightly strange way to write out the problem. What we have for our unknowns are N3, N4, N5, N6, N7, N8, and N9, and all of our equations will be in terms of these variables. Next, we write all of our equations in terms of our unknowns. We need to make sure that all of our unknowns are on the left-hand side of the equation and all of our knowns are on the right-hand side of the equation. This way we can enter them all into a matrix in Excel and solve the problem. What this means is that for total moles out, we have to subtract N3 to move it over to the left side of the equation. For the fractional conversion, we need to solve so that N7 is on the left and N1 is on the right. For fractional O2 and fractional NO, the procedure is basically the same. We need to subtract over our N3 so that both of our unknowns are on the same side of the equation. We begin by setting up our inputs. N1 is 100 moles per hour of 100% NH3. N2 is 1000 moles per hour of 0.21% O2 and 0.79% N2. We now set up columns for oxygen, nitrogen, and hydrogen. NH3 has 0 oxygen, 1 nitrogen, 3 hydrogen. Oxygen has 2 oxygen, 0 nitrogen, 0 hydrogen. N2 has 0 oxygen, 2 nitrogen, 0 hydrogen. We now set up our output columns. N3, N4, N5, N6, N7, N8, and N9, which is the total moles, the moles of O2, the moles of NO, the moles of N2, the moles of NH3, the moles of H2O, and the moles of NO2. We now set up our entries for oxygen, nitrogen, and hydrogen, and set how many of each atom there is for each one of these compounds, just like we did in the first part. This is done to make our calculations down below simpler, faster, and less error-prone. We will now set up our calculation table with one row for each equation: oxygen, nitrogen, hydrogen, the total number of moles out, our conversion percent, and our two fractional conversion equations. The columns will be our unknowns: N4, N5, N6, N7, N8, N9, and N3. We will now enter in all of our equations that we have previously defined. For the oxygen, nitrogen, and hydrogen balances, what I'm doing is using a cell reference to pull how much oxygen, nitrogen, and hydrogen goes with each of N4, N5, N6, N7, N8, and N9 using the table up above. I'm doing the same thing for the oxygen output. I'm just simply adding up all of the oxygen that goes into the system. I did this in order to make it a lot quicker and easier to perform these calculations, to make it so you're always entering numbers the same way so that you're not going to make a mistake, and because this makes it a lot more flexible, because if you've made a mistake in how much oxygen, nitrogen, or hydrogen is in something, you can correct it in one place and it will automatically fix itself. After this, all we are doing is entering in the rest of our equations that we've previously defined. You set any variable that isn't in these equations to 0. We now set up the answer section of our table. N4, N5, N6, N7, N8, N9, N3, and then we select the region next to it. We set this region equal to M mult of M inverse of our data area and multiply it by our answer column and then hit Control-Shift-Enter. We now have a live calculating Excel table. Notice how as you change N to N, the output changes, and for some inputs there is no physically possible output. Thank you for watching the screencast. I hope you found it useful.